Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized conversations. Today, we're looking at how we can teach AI to understand the world more like we do by both watching and listening.
That's right. When you watch a video, you're getting two streams of information at once, what you see and what you hear. A dog barking, a car driving by, a person talking. The sight and sound are intrinsically linked, but for a long time, teaching AI to learn from both at once has been surprisingly difficult.
Most approaches have used what you could think of as two separate brains for the AI. One brain, called an encoder, would process the video frames, and a totally separate brain would process the audio. Then you'd have to build this complicated bridge between them to make sure they were on the same page.
And it gets worse. Researchers found that if you tried to be efficient and just use one single brain for both audio and video, the AI actually got dumber. It became worse at understanding video and worse at understanding audio. It was like forcing two different specialists to share an office, and suddenly neither can do their job properly.
But a new paper from researchers at Meta and NYU called MJEPA, a simple and scalable joint-embedding predictive architecture for audio-visual learning, says they've cracked the code with a much simpler, more elegant solution.
MJEPA, which you could say MJEPA, throws out the idea of two brains and complex bridges. It goes all in on a single unified encoder, one brain to process everything. The secret ingredient that makes it all work is a very simple game.
The game is guess the missing piece. The AI is shown a video, but parts of it are hidden. Imagine you're watching a clip of a guitar player, but the AI covers up the guitar with a big gray box. Based on the sound of the strumming, the AI has to predict what the image in that box looks like.
And it works the other way too. It might show the AI the video of the person's fingers moving on the fretboard, but mute the audio for a second. The AI then has to predict what the missing sound was. The paper calls this cross-modal prediction, using one mode, like audio, to predict another, like video.
And this turns out to be the absolute key. The researchers show that without this cross-modal guessing game, the single AI brain gets confused and performance drops. But when you force it to predict sight from sound and sound from sight, everything clicks into place. The two senses start helping each other.
The AI starts to learn the deep connections between things. It learns that a certain visual of a dog opening its mouth corresponds to a bark sound. It learns that the image of rain hitting a window corresponds to a pitter-patter sound. It's building a richer, more unified understanding of the world.
So the idea is wonderfully simple, but does it actually work? Well, the results are pretty stunning. They tested MJEPA on a range of standard tasks, like identifying different sounds or actions in videos.
On a benchmark called AudioSet 20K, MJEPA didn't just do well, it set a new state-of-the-art, outperforming previous more complex models by a huge margin. It was better at identifying events using audio alone, video alone, and both together.
And what's really impressive is how generalizable its knowledge is. In many AI tests, you take a pre-trained model and then fine-tune it, or retrain it heavily for a specific new task. With MJEPA, they often just froze the core brain. They didn't let it change at all and just attached a small new module for the task.
And even in this frozen state, MJEPA often beat other models that were fully fine-tuned. That tells you that the fundamental understanding it learned from playing its guessing game is incredibly robust and useful across many different situations.
The simplicity of the design also means it's incredibly scalable. They were able to train a version with over 1 billion parameters. They fed it more and more data, including a massive dataset of videos that had no sound at all.
And here's the wild part. By watching more silent videos, the model actually got better at understanding audio. Because it had built such a strong internal model of how the world looks and moves, that visual knowledge helped it make better predictions and improve its audio processing skills. The synergy was real.
So the big takeaway here is that to get an AI to learn from sight and sound together, you don't necessarily need a more complex architecture. You just need to give it the right task.
Exactly. By creating a single unified model and forcing it to constantly predict one sense from the other, MJEPA learns a powerful and flexible representation of the world. It's a great example of how a simple, elegant idea can outperform years of complex engineering.
It paves the way for AI that can learn more holistically, not just from audio and video, but potentially from any number of data streams: text, touch, depth, all within one unified framework.
A simple game of hide and seek with the senses might just be the future of how AI learns.
That's all for this episode of Daily Papers. Thanks for tuning in.